Welcome to another Getting Started video for Octopus Deploy. This video will cover workers and worker pools. By the end of this video, you should have a better understanding of how workers and worker pools work, when to use workers and when not to use workers, and finally, recommendations on leveraging worker pools. Before jumping into the demo, it is important to understand how workers and worker pools work at a high level. At first, it can seem there's not much difference between a worker and a deployment target. If you're unfamiliar with deployment targets, please click on the link which just appeared in the top right corner of the screen. A deployment target and a worker can run on Linux, Windows, or Mac. For Linux and Windows, you can also install a tentacle running in listening or polling mode. The key difference is how those tentacles are registered and used with Octopus Deploy. With deployment targets, you specify the role, such as Hello World API, in the deployment process. During a deployment, Octopus Deploy will select all the servers in a specific environment matching that role. In this example, all 3 servers in the development environment were chosen because they all have the Hello World API role. Workers are different. Workers are assigned to a worker pool, which is specified in the deployment process. During a deployment, one of the workers is leased from the pool, the necessary work is done on the worker, and the worker is added back into the pool. The reason for this difference is due to the kind of work being done on the tentacle. With a deployment target, the process needs to deploy something, such as a website or a service, on all the deployment targets. To properly configure an application, the tentacle needs direct access to the server. Whereas with workers, the deployment needs to invoke an API. For example, doing a deployment to a Kubernetes cluster is typically done via a CLI known as kubectl. kubectl connects to Kubernetes clusters via admin endpoints. Another example is a database deployment, where you're invoking SQL commands over a specific port, such as 1433. There are several advantages to this approach. The first is security, as the worker pool can be placed in the same location as the deployment target. In this example, port 1433 is only open to servers running in the same VPC up in AWS as the database. The worker connects to the Octopus server over port 10943 and sends commands to the database over port 1433. The worker and server have a two-way trust relationship established by exchanging certificates as part of the registration process. This means the server won't accept connection from workers it does not trust, and the worker will not connect to and run commands from a server it doesn't trust either. Another advantage is workers can run as specific domain accounts. This means you can create a worker pool per environment, each running as a different domain account. Using the database example again, this diagram has workers running as domain accounts, which has access to a limited number of SQL servers in specific environments. The next advantage is performance and maintainability. The work done by workers has to be done somewhere. Without workers, that typically means on the Octopus Deploy server itself. This puts additional burden on the server, as it is also responsible for handling web requests from the UI and orchestrating deployments to targets. In addition to that, more software has to be installed on the server, which means more maintenance and resource consumption. Workers offload that responsibility. Worker pools can be created for specific tasks, such as database or Kubernetes deployments. Any additional software is installed on the workers, not on the server. Let's see this all in action. This demo will walk through creating a new worker pool, registering a worker to that new pool, and then updating the Hello World project. This demo assumes you have a listening tentacle installed on a server. If you do not have a listening tentacle installed, please click on the annotation which just appeared in the top right corner to see the instructions. To create a worker pool, click on the infrastructure link in the top menu. Then click on Worker Pools in the left menu. All instances of Octopus Deploy have a default worker pool automatically created. We're going to leave that pool alone for this particular demo. Changing it could affect any existing steps configured to target that worker pool or run on the Octopus Deploy server. To add a new worker pool, click on the Add Worker Pool button in the top right corner. Give the worker pool a name and click the Save button. A worker pool without a worker isn't much use. Let's remedy that by clicking on the Add Worker button. A worker can run on Windows as a listening or polling tentacle. It can also run on Linux as a listening or polling tentacle, as well as via an SSH connection, while Macs only support SSH. For this demo, we'll be using a Windows listening tentacle. Enter in the hostname of the machine running the tentacle and click the Next button. Give the worker a name. The name should be descriptive yet succinct. For example, if this worker is to be used for Kubernetes deployments, the recommendation is K8's Worker 01 or K8's Worker 02, and so on. For database deployments, DB Worker 01 will work just fine. Select the worker pool from the drop-down list. Depending on how you got to this page, the worker pool may already be pre-selected. Click Save. Congratulations! You've just configured your first worker pool and worker. Next, we will update a project's deployment process to leverage that new worker pool. Navigating to the deployment process for the Hello World project will show the step is now running on the default worker pool. Before the new worker pool was added, the step indicated it ran on the Octopus Deploy server. That has now changed. When the default worker pool does not have any workers in it, it will run any tasks assigned to it on the Octopus Deploy server. For Octopus Cloud users, the default worker pool is a dynamic worker pool, which means a dedicated VM is dynamically added as a worker to the pool on demand. We can change the pool to be one created for this particular demo. However, there is another option. Below the worker pool drop-down list is a new option added in 2020.1. That new option allows a worker pool to be selected dynamically at runtime via a variable. Let's go ahead and configure that. Clicking on the variable link in the left menu opens up the project variables. Give the variable a name and change the value type to be a worker pool. Select a worker pool from the modal window and click Done. The advantage to this option is worker pools can be scoped to different environments. Click the Save button and navigate back to the process. Now select the variable from the drop-down list and click the Save button. That is it. Now the deployment process will leverage the new worker pool via the worker pool variable. Here are some tips to keep in mind when configuring workers and worker pools in your Octopus Deploy instance. Leverage workers to increase performance and security whenever possible. It is much better to run a task on a worker than directly on the Octopus Deploy server. Create task-specific and/or location-specific worker pools. For example, if you are deploying to a Kubernetes cluster in AWS, have an AWS Kubernetes worker pool. And finally, leverage the worker pool variable type whenever possible. This makes it easier to change worker pools down the line, or if you have to isolate worker pools per environment. Links to additional resources, as well as links to contact support, can be found in the description below. Thank you for watching, and happy deployments!